morning to you all. My name is Mr. Augustine, the physics teacher from Miller Road section. Actually, I'm here to talk about transformer. And it's all known, transformer can be defined as a device that is used to step up or step down the voltage or current in an electrical system. Okay, we have our four objectives here. Number one, definition of transformer. Number two, types of transformer based on purpose and construction. Number three, transformer calculations. And number four, energy losses in a transformer. Okay, I'll start with the number one, definition of transformers. Okay, a transformer is defined as a device that is used to either step up or step down the current or voltage in an electrical system. Now we have the types of transformer based on purpose and construction. Now based on purpose, transformer can be classified based on purpose and based on construction. Now based on construction, we have the shell type and we have the core type transformer. Okay, but actually we are going to talk about under based on what purpose. Now based on purpose, we have two types. That is the step up transformer and the step down transformer. Now for the step up transformer, as you can see from the diagram here, we have the step up transformer and we have the step down transformer. Now, what is the difference between these two diagrams? You know, every transformer will have three main parts in the transformer. We have the coil, we have the core. Now we have the two coils, the primary coil and the secondary coil. Now we have the core, and the core can either be an iron or a steel plate. Now, in a step-up transformer, the number of coil in the secondary is greater than the number of coil in the primary. Now, for the step-down transformer, the number of coil in the primary coil is greater than the number of coil in the secondary. That means the higher the number of turn or coil, the higher the voltage and the lower the current. Now take a look at the step-up transformer. We have less number of turn in the primary. That means we have a higher current in the primary than that of the secondary coil. Now for the step-down transformer, we have a higher number of turns in the primary than in the secondary. That means we have a lesser current here and we have a higher current. We have high number of turn, high voltage and low current. While here, low number of turn, low voltage and high current. Now, what is the difference between primary coil and secondary coil? Primary coil is the input coil. When I say input coil, that is the point in which current enters through the transformer. Current enters through the primary coil and leaves through the secondary coil. I think I've explained under purpose. Now I have transformer calculation. Now, based on the transformer calculation, I'm going to explain the calculation that you need to know in a transformer. Now, since in a transformer we have the number of turn. Number of turn is equal to what? E. And let's use N as number of turn. Then voltage, let's use what? E, and the current is what? I. Please, in a short way, you can remember this by using what we call any. We have the voltage, the number of turn, and the current. Now, what happened in this calculation for transformer? Now we have any. Since we said the higher the voltage, the higher the turns, and the lower the current. That means the voltage across the primary is equal to what? Or over the voltage across the secondary is equal to what? Number of turns in the primary over number of turns in the what? secondary, and is equal to what? Current in the secondary over current in the primary. That means voltage is increasing, number of turns is increasing, and the current is what? Decreasing. Okay, that's the first transformer calculation. Then number 2, we are going to talk about the efficiency of a transformer. Now when we say efficiency is equal to what? Power output over the power input times 100. Now when we say power output and power input, now we said current enters through the primary coil and leaves through the secondary coil. That means the power output is for the what? The secondary coil, while the power input is for the primary coil. Now, from the definition of power is equal to what? The current times what? The voltage. Now, when we say power is equal to the current multiplied by the voltage, now that means efficiency of a transformer is equal to power output, that is power from the secondary coil, which is what? I, current in the secondary, multiplied by what? The voltage, which is what? E in the secondary, all over what? Power input. That's the what? The primary coil. Current in the what? Primary times what? Voltage in the what? Primary times 100. Now we also have the current in the secondary multiplied by the voltage in the secondary over what? Current in primary times what? The voltage in what? Primary times what? 100. Another thing we need to talk about is what? The transformer ratio. The ratio, which is also called the number of turns. Now, the ratio is equal to what? Number of turns in the primary over number of turns in the secondary. It is called the transformer ratio. Now, this transformer ratio, when the number of turns in the primary, or when the transformer ratio, when the ratio number of turns in primary over number of turns in secondary is greater than 1, it is called what? A step up transformer. A step up, but number of turns in primary over number of turns in secondary is less than 1. It's equal to what? A step down transformer. Okay, I think I've explained this. Now let's come to the examples. Okay, from the question we said a transformer supplies 12 volts, that is voltage across the secondary 12 volts when connected to a 240 main. The 240 main is the primary voltage. If the transformer takes 0.12 ampere from the main, that is what? The current across the primary from the main. When used to light a 12 volts, the 12 volts is the what? The voltage output of the transformer. 24 watts lamp, that is the power output. What is its efficiency? As you all know, efficiency is equal to power output over power input times 100, which is what? The power output is what? 24 all over. Now what is the power input? The power input is the current across the primary multiplied by what? Voltage across the primary. Now what is the current across the primary? 0.12 times what? The voltage across the primary is what? 240 multiplied by 100. Now what do we have? 24 all over 0.12 times 240 is equal to 28.8 times 100. Now if we divide everything here, 24 divided by, we are going to have 83.3%. That means the efficiency of the transformer is 83.3%. I believe you can solve this kind of question. Please, you have your past question and answer. Please go to WAEC past question and answer 2002 question 42, 2008 question 43. Also in NECO past question, you also get this kind of question: 2005 question 50, 2007 question 48, and 2009 question 49. I also have an assignment for you. Now assignment 1, give 2 reasons why the core of a transformer is laminated. Assignment 2, given the data below, find the number of turns in the secondary. The data are: turn ratio is 3, number of turns in primary is 300, current in secondary is what, 5 ampere, and efficiency is 80%. From what I've explained so far, this is a typical example of a transformer. We have the primary coil, we have the secondary. This is the power input and this is the power output. This is the core of the transformer. Inside it we have the coil, and the coil is usually laminated. And energy is usually lost during a transformer. There are some energy losses during transformer. We have about 3 to 4 energy losses during transformer. Number 1, we have the eddy current. Now energy is lost as a result of what? Eddy current. Now how can we minimize the energy lost as a result of eddy current? That is why we are laminating the coil. We laminate the core and the coil. We are trying to minimize energy loss as a result of eddy current. Number 2, we have the hysteresis loss. Now when we say the hysteresis loss, this energy loss as a result of what? The magnetization and magnetization of the what? The core inside the transformer. Now how can we minimize the energy loss? We can minimize it by using an efficient core design. We should make sure we design the core in such a way that it can minimize the energy loss due to what? Hysteresis loss. We have the copper loss. Now when we say copper loss is as a result of what? Heating of the coil. Energy is lost as a result of heating of the coil, and which we can also minimize by using a copper or an efficient copper, which can minimize the heat loss as a result of what? Heating. Okay, thank you very much. I believe with all this explanation, you can solve questions on transformer. And please, I advise you try to do your assignment and submit it online, because I'm going to mark, and if possible, I'll send it to work. Thank you very much.